A very good morning to you, ladies and gentlemen. Welcome to this year's first edition of Makers and Movers, a talk series where we have leaders from the manufacturing and supply chain sectors talk about technology and trends. We are privileged to have a thought leader of the manufacturing industry with us, who is also an authority on 3D printing. I'll introduce you to him very soon. And before that, I let me share with you a few nuggets of information on what we have to discuss today. As you know, we are talking about the 3D printing industry. Now, this industry is said to be of the size of $12.6 billion in 2021. The Indian 3D printer market stood at about $92 million in 2020. But, ladies and gentlemen, it's not about the market size of any industry, in my opinion, that really matters. What really matters is how that industry impacts and influences our work, our livelihoods, and our lives. Now, 3D printing is really beginning to have an impact here. I'll give an example of the healthcare sector. 3D printing is helping us make custom made prosthesis and artificial tissue, helping us with facial reconstructions and with life saving customized surgical tools. These are some of the many examples of how 3D printing is really helping people in India and globally. Within the industry, there are sectors such as mobility, such as EVs, for example, which has a big use case for 3D printing technology. The aerospace industry, the drone industry, which is a fast growing industry. So now these are the industries which are using 3D printing technology in a big way. We have the good fortune of having Rajiv Bajaj, Managing Director of Stratasys India and SEA, who will share with me insights on 3D printing, which is also called additive manufacturing, and its amazing, wonderful industry applications. Rajiv is not only a part of the leadership team of a spectacularly successful 3D tech company, but he is also an authority on the technology and its various applications. Let me quickly share with you his illustrious work profile with you. With over 20 years of experience in the technology industry, Rajiv leads Stratasys India that is, and SEA for the last over 7 years to drive sustainable growth of additive manufacturing in the region. Rajiv has extensive experience in the manufacturing industry in driving business transformation. He participates as a speaker in leading industry forums like the CII, ACMA, and IMTMA on driving innovation through technology adoption in aerospace, automotive, and consumer goods industries. Prior to this, Rajiv was the country manager at Autodesk India and SARC, heading the manufacturing solutions business unit and managing the growth strategy across different industry segments. He has held positions with leading product lifecycle management companies, including Dassault Systems and PTC, playing an instrumental role in sales and sales management. Welcome to our forum, Rajiv.
Thank you, Anand, and it's a pleasure to be here on your show, aptly called the Makers and Movers for the manufacturers and the supply chain all inclusive. And it's an interesting field to be in. Additive manufacturing today is by virtue of playing in the overall scope of manufacturing industry and transforming it, it's actually expected to grow from the current figures of $12 billion you said to almost 100 billion by the end of 2030, just by revolutionizing the way we do things and the way manufacturing is done. So pleasure to be here and looking forward to a meaningful conversation.
Thanks so much, Rajiv. Now, about this technology and the industry, this is like an industry where everybody wants to know more about the technology industry, but not many people know the kind of influence and the oversized influence in this case that the technology is having on people's lives. So, from an industrial perspective, Rajiv, and that's where my first question comes from, is that additive manufacturing or 3D printing is said to be the fourth emerging field of manufacturing after subtractive forming and casting. In the overall spectrum of manufacturing technologies, where do you see a fit for 3D printing?
Great. And it's a question that actually a lot of people ask us because they see it as something very new, something that was kind of innovated last couple of years and is now into moving into mainstream. But the fact is that this technology today is almost 30 plus year old. Scott Crumb, the founder of Stratasys, is also the founder of 3D printing FDM technology. And in multiple areas of our work and life, it is playing a key role in transforming the way we work, the way we innovate, and the way we play, etc. Looking at the traditional ways of manufacturing, additive manufacturing actually cuts across segments, and in some ways, it is a standalone solution to some of the manufacturing methods. And in multiple other ways, it complements the way you are manufacturing things already. So successful enterprises today are using a good mix and match of additive and subtractive, also forming, also sheet metal manufacturing and casting, etc., to ensure that they are able to optimize their process and cut down their product development cycle times significantly. So it's not a tool in isolation that is driving the entire Industry 4.0 revolution. It is a part of the overall scheme of things, and its role is becoming increasingly important as the industry itself moves from a prototyping stage to mainstream manufacturing. And I think in a few years from now, additives role into mainstream manufacturing is going to become very big because the technologies are now getting oriented towards choices of materials, faster manufacturing, and lower cost per part.
Now, Rajiv, I want to explore more about its influence and impact for the machine tools industry, as our readers and viewers are from that field. But there is an application which touches the lives of everybody who's tuning in, and that is the healthcare industry. And I was amazed to find recently that its applications in surgery, for example, uh, for joint reconstruction or facial reconstruction, for skin grafting, these are really critical applications that are saving millions of lives worldwide. And these are the applications that we barely know about. So, Rajiv, can you enlighten us
Sure,
on its
sure, sure,
various uses in the healthcare industry?
sure. Actually, my personal opinion of all the things that we do for the industry, everything is calculated on ROI, faster time to market, and so on. But I think you can never put a cost to human lives or a life that you save. So additive manufacturing plays a huge role in improving human lives as well as improving surgical outcomes to make patients from inoperable to operable to healthy. There have been instances where in some discussions with the pediatric surgeons, I realized that in many areas of our country, surgeons do not touch a newborn baby who has some heart defects because of the complexities of the surgery involved and the kind of accurate information they need for surgical planning. And technologies like 3D printing play a very vital role in making the anatomy of the individual, of the infant, to the truest size in the accuracy is required so that the surgeon can have a look and feel before opening up the baby and conducting a successful surgery. So these are some of the areas where it's playing a big role. Other than that, cases where people in our own country, these are the cases that I'm talking about, where patients have suffered with kidney cancer. It's a procedure called nephrectomy, a partial nephrectomy, in which they remove a part of the kidney and only leave the healthy tissues behind. Now, to visualize a cancerous tissue with 2D scans is next to impossible. But once you have that same kidney model in various colors, accurately depicting the cancer tissue in the kidney, gives a very clear idea to the surgeon as to what he needs to remove and what he needs to conserve in the patient's kidney. And there are multiple such cases cutting across heart surgeries, brain implants, maxillofacial, which you already talked about, prosthetics in which people have lost a limb and we custom design a limb for them to be able to walk successfully. And human body by nature actually is tuned for a process like additive manufacturing because everything is custom. No two human bodies are same. No two anatomies are ever similar. So to be able to successfully drive a surgery outcome or to plan a prosthetic, you need to have exact measurements of the patient. And that's where the industry actually is revolutionizing the outcomes of surgeries as well as patients' lives.
Thanks so much, Rajiv. There is a related area. Can you hear me? Is my voice?
Okay.
Awesome. There is a related area which is not as critical for healthcare, but as exciting. This is the area of aligners, teeth aligners. And a lot of us are seeing a lot of ads from startups that are being built around this concept
Correct.
of straightening our teeth. Now, Indians have generally not been very looks conscious, but 3D printing is changing all that. So, can you tell us about its application in the area of teeth straightening? How easy or difficult does it make the whole process, and how this concept is spreading in India and the world?
Correct. So not just clear aligners, which I'll come to in a second, 3D printing addresses the entire digital dentistry workflow. So starting from crowns and bridges, which are also very patient specific, to dentures, to clear aligners, there are multiple outcomes from 3D printing that are changing people's life. And why clear aligners has caught everybody's attention because it is cosmetic and it is visible. The traditional way of straightening one's teeth was to wear braces, which kind of don't look so good. And people have some reservations against wearing those wired braces. And with 3D printing, this concept of clear aligners came, where a patient's teeth are scanned and through virtual programming, clear aligners, which are absolutely clear. You wear them on the teeth, they're not visible, and you go about doing your daily chores without any problem. And in 6 months to a year's time, your teeth are absolutely smile friendly. That's one. But in certain cases, there are certain inherent defects with the teeth that this aligner solutions also solves, which are more complicated, and doctors' inputs are required for making that viable. So we have multiple use cases within the country. 3D Future Technologies, a company based out of Pune, which makes flash clear aligners, has been our partner for a while, and they have helped multiple people not only with straightening teeth for cosmetic reasons, but also for medical reasons.
Now let's move to the industry and its applications. What are the various industrial sectors, Rajiv, where this technology is being used? From, let's say, the aerospace industry at one end of the spectrum in terms of innovation, where it's used in design, is being utilized the world over. For sustainability, for example, for better more aerodynamic design. To the other end of the spectrum, which is more heavy industrial use, let's say to the machine tools industry. So what are these different sectors where this is being used?
So by virtue of the flexibility that 3D printing as a process provides, it's applicable to every single manufacturing need of a customer. But primarily, the biggest adoption so far has happened globally and in India in the automotive sector, in aerospace, and in consumer goods and consumer packaged goods. Now, these are some of the industries that drive cutting edge innovation across other manufacturing technologies also, and additive manufacturing is no different from there. But a new wave of startups also adopting this in medical devices, in products like drones. So these companies are newer age manufacturing organizations, I would call, whose shop floor looks very different, whose shop floor is not a traditional shop floor with hundreds of injection molding machines and multiple CNC machines, 3-axis, 5-axis, conventional, and so on. These are very modern workshops which have a series of additive manufacturing technology working for them. Plus, now automation is also coming to additive manufacturing. Because as we move towards manufacturing, we need to become more and more autonomous. That means you can involve robots, you can involve programming, you can automate some of the post-processing tasks, etc. So besides the big names in the industry, there are a lot of small names with very specific requirements of products, especially in medical devices, which I think India is a big hub for medical devices. A lot of entrepreneurial work is going on in the industry, and also in drones and electric vehicles that we discussed about earlier.
Now, there is a question that has always piqued my curiosity. I remember, and this is about the awareness about the technology. I'm just taking a step back and going to talk about how people perceive it in India, because that is very important for an emerging and a disruptive technology such as this, and disruptive in a positive way, of course. So I remember, for example, an industry conference which happened a few years ago at the campus of one of the biggest companies in India, and the session was on 3D printing, and the speaker was also from a very reputed industry, a software industry, but a leading. Uh, Now I remember taking the impression back that not many people from that gathering understood its real implications on the ground. In fact, uh, at one point in the event, it was not going very well. So the speaker invited whoever in the audience who could make him understand better about the technology. Because most everyone was clueless. Everybody knew that this is a great technology.
Correct.
This is something heavy coming our way, and we are going to do great things with it. Much like what blockchain was, let's say 2 3 years ago, before it
Agreed.
hit a patch. But 3D printing has actually translated into real world applications beyond the use cases that we still hear about blockchain. Right. So, how do you see this transformation, and what do you attribute the lack of awareness around it, about the technology?
Sure. It's an interesting question. Actually, it reminds me, I mean, it's on a lighter note about an article I read somewhere that Albert Einstein was trying to explain quantum physics to a set of professors. He explained a new concept and he asked, did anyone understand? So one guy raised his hand. He said, why don't you come and explain it to the rest? So he came there and he said, now I forgot. But 3D printing is not as complicated. 3D printing is not as complicated. And it's a very here and now technology. See, a lot of people perceive it as something which is competing with the traditional manufacturing. It's something very different. We'll have to change everything that we are doing currently and bring up multiple new equipment and so on. But in reality, it's the easiest way to fast track your product development process, and in multiple ways. Start with prototyping. Today, most companies take between weeks and months to develop a new prototype, depending on the product quality, type, innovation angle involved, the complexities of the mold making, and so on. If you have a 3D printer, you can do same things that you were doing in months, in days, and weeks to hours. And that's exactly what companies like Ashok Leyland have done using technology when they had to develop something for their truck. Companies like Minda, when they are developing some new projects for the upcoming Auto Expo. Companies like Veroc. I mean, so it's an integral part of the process. Now, people who've been using this technology for a while, they now started pushing the boundaries and they said, prototyping is great, let's use it on manufacturing. So very specific use cases of making jigs, fixtures, drill guides, even bending tools for sheet metal. It becomes more and more integral part of the process. And once somebody starts using it, the kind of extrapolation that they do for their own products is much higher than somebody like us can tell them to use a 3D printer for. Right? So it's like giving a toy to a child and then he starts figuring out new ways of playing with it and so on. So that's something which is very good. On the part of limited knowledge, that I would say there are a few factors that I would say. First of all, as industry leaders and thought leaders, a lot of the responsibility is on us to work with industries, education institutes, scientific labs, etc., to make them aware what technology can do. Another issue that has come, especially in our cost-conscious countries like India, is that people start experimenting with 3D printing technology with very affordable entry-level 3D printers, saying that they will solve their industrial problems. But in the end, they don't end up doing that because of the complexities also involved. Because 3D printing, if you want exact outcomes, you need that quality of a printer. And then they start believing that this technology may not work for them, it's not best in class, and so on and so forth. So there is a lot of confusion going on in people's minds. But most people who have adopted an industrial 3D printer in their product development process have recovered their ROIs. I mean, I'll give you a case of Honda. They calculated 3 years ROI for their first machine that they bought from us. They recovered their ROI in 6 months and they invested in another machine. So that's how it goes. So once a customer adopted in their mainstream processes, they become far more knowledgeable than us in their applications of 3D printing, I would say.
Absolutely. You raised a very, very pertinent point to me, which is about the traditional manufacturing processes, the mainstream manufacturing processes. And Rajiv, from a media perspective, when we look at trends, and especially technological trends, we find a distinct pattern and difference between the technologies that are embraced and become go on to become a part of the mainstream and those that do not. The biggest difference is that they do not disrupt or upend the industry. They are uh, absorbed into the industry as being one of the many streams. That is the crucial difference. So when these technologies come up, people say that, oh, they are going to, for example, let's say Netflix, just giving an example from the overall perspective, or online sales or e-commerce. So when they came up, everybody in the business got a little bit insecure that it's going to upend the whole business model. But they became a part of the overall omni channel
Omnichannel,
or
yeah.
hybrid business model, and now they are being transformed as one thing that is being used by even mainstream operators, is the point I'm trying to get at.
Correct.
Now 3D printing, I see that it stands at the threshold or at the cusp of this change into becoming one of the mainstreams technologies. What is your view about this?
I actually quite agree with you on this point. So till so far, let's say in the last 3-4 years, we are seeing that 3D printing is evolving from just a prototyping lab or a industrial design studio lab application to something that can solve people's challenges in mainstream production, in new concepts like hyper personalization, in concepts like end use parts. So today we have technologies available, and Status has recently also, just a case in point, has invested in some of new technologies that bring cost per part very low, the time to print the part very fast, and matching the accuracies and the finish that a person would need for end use applications. Now, till some time back, this was limited only to a few tens or hundreds of parts. But today you can actually get into batch and mass production using additive manufacturing. So as the industry itself pushes towards manufacturing with additive, that is the point when it becomes the overall part of the product development life cycle and not just limited to the design studio of a company. And there are, I mean, again, I would, at the point of repeating Honda's success story, they increased the usage in Honda CL cars in India. They increased the usage because they did not put their machine in an air-conditioned prototyping lab, because they don't design cars in India, by the way. So they put it on the manufacturing shop floor, and they see the adoption was so fast. The same people who were little resistive to putting a new technology in their existing workflow, actually they adopted it, and today all of them are making new ways of quality improvement using additive. So they are now able to measure very complex surfaces, which they were earlier not able to because of the complexities involved in sheet metal bending, etc., because they were using metal tools earlier. Today they just use the CAD data that is readily available. They design a tool and it's become an integral part of the process. So now, as the industry is going, it's moving towards applications, as people are understanding it a bit better, it is going to become mainstream. And I think one fear or a doubt people had that it is going to take away mass manufacturing away in the near foreseeable future, that's not happening. So much so that you will see a lot of CNC manufacturers in India and globally who are having their own automation companies that do additive manufacturing. So when they give a complete solution of setting up a line for a new, let's say, automotive manufacturer, they will say, okay, this much work will be done by CNC machine, this much will be done by additive manufacturing and robotics. So anywhere you have complexities involved, you can introduce additive manufacturing very quickly. And special requirements like Auto Expo, you have to come out with 10 new concept models. Most of us are engineers, right? When did we study? On the last day of the exam. I think that trend continues in the industry. Everybody is right now working on models for Auto Expo. And when is Auto Expo? Next week.
Absolutely. Speaking of which, Rajiv, so what do you think about this trend? Or let me stick to
Sure.
the line of questioning, because this is such an important topic and so much to talk about. So let's first dispel the biggest myths around this area. Now, one question that comes from a lot of our readers is that at what stage does your company come in? I'll give you a quick backgrounder of where our readers come from. So, one is that the technology heads of companies say that, okay, for sustainability, we need to look at new designs, new models. And this is where we need to consult somebody from the 3D printing industry. So that's at the stage of product development,
Correct.
the beginning of the process. But then there are areas like in healthcare where suddenly towards the middle of a process, people feel that this is a requirement only 3D printing can fulfill. So, what are the different stages in which your companies and you as an expert step in for people?
I think I'll try to clarify it with a few customer examples so that we can connect the dots. Because there's no straitjacket fit, there's no single solution for any technology that you would implement. So I'll give you an example of a company called Yazaki, who we work with very closely. So now Yazaki, as most of the listeners would know, is a company that makes wire harnesses and junction box, which essentially becomes the central nervous system of the vehicles that we drive, both for convenience, comfort, as well as safety today, because a lot of safety involvement is through electronics. Now, when they are talking to the OEM like Ashok Leyland or Maruti or Mahindra, they are supposed to today package all of the stuff in a very small junction box. These are very new ideas. And if you are able to not only design that junction box, but also 3D print it within a matter of few hours and give a solution that the OEM can fit into the vehicle and check, it really drives the product innovation. Now people are not scared to innovate, thinking that if I make too many changes, will the mold maker give me the soft tooling faster? Will I delay the process? No. Today, even if you are printing the part, you get a new idea. You stop the printer there, implement the new idea, print a new part in the next 8 hours, and it's ready for you. So that fear of innovating or fear of failure is totally taken out from the equation, and people have all the design freedom, all the new thinking that they want to implement in their product innovation. How does it help them? It helps them to give a complete solution to the OEM and win the contract, because they are not the only ones bidding for a project. Somebody else would also bid. So if they are able to give a more comprehensive solution, they better package it in a smaller junction box and give more features, they will win. So that's the problem solved at the product development stage. Secondly, there are certain examples where they need to take a quick call on localization of a product. Let's say a lot of OEMs, sometimes they bring their outside car, they want to do some localization, they want to take a quick call. So they are able to make those adjustments, those changes, check for homologation, etc., using 3D printing and take a quick call. And I mean, I have instances of customers, I can't name them, that they've saved a few $1 million by choosing not to launch that vehicle in India, which was successful elsewhere in the world. Then coming to applications like healthcare, where it generally is a matter of hours most times, because if there is a critical patient, and sometimes these life-threatening diseases get discovered much later, and then the decision has to be taken within a matter of day or a few hours, and that's where we recreate these scans into a 3D model, and giving the exact interface with the cutting knife, etc., where the surgical knife, the surgeon can practice the entire surgery, and then have a more predictable surgery outcome than they would have done in the past. And not only that, it reduces, look at a few other outcomes. It reduces the surgery time from, let's say, 10 hours to only 2 or 3 hours. Why? Because the doctor was 100% clear and he was not seeing 2D designs. And typically what happens, a surgeon meets a radiologist before the surgery. Radiologist explains what he has made up the outcome of those images in his mind, and that's how the anatomy would look like when they open up the patient. But imagine giving them a complete 3D model and telling them this is how the heart looks like, this is how the kidney is, and so on, and then preparing them for the surgery. Now, every hour that the patient spends on surgery, he is on a pulmonary bypass system, which means he is using artificial ways to pump the heart and so on, and which also reduces the overall health benefit that the patient gets in such cases is multiple times more. And eventually, the same surgeon, the same skilled surgeon, is able to do more surgeries in the day than he would have done in the past. So these are some of the applications, if I think I have explained it to you.
Wow.
That is good.
This really fascinates me, Rajiv, because the technologies that are used by high innovation industries and mission critical industries like healthcare and aerospace should be implemented more, adopted more across the sectors and at an initial stage, at the planning stage. Now, my next question stems from there, that in an ideal world, like the analogy that you shared with us was a surgeon discussing with the radiologist and then going into that process, which can save a life. Now, if we use the same analogy in manufacturing, right? Even before, and there are examples of product life cycle management companies using your expertise right at the beginning of a product development stage. So, ideally, at what stage should companies bring 3D printing experts into the equation?
I would say as early as possible. But then again, there is no straightforward approach. A lot of people do it in a reactive way. So much so that when COVID struck and people had issues with their supply chains and issues with getting their sample parts from overseas, they all moved to 3D printing for help. And it did help in a big way by reducing their dependence on the supply chain, and they were able to give the same output that they were planning to. Now, where should it fit in? My assessment today at the state that we are in 3D printing, if somebody is thinking of adopting 3D printing, he's already 10 years late. Yeah, if he's thinking of taking 3D printing to the shop floor, he's already 4 years late. And if he's thinking of taking 3D printing into end-use part production and use it as a batch to mass production technique, maybe he is within current times of this current year. And this technology now cuts across domains. So you have technologies available helping you for form, fit, and function, this fixture kind of requirement where you need more stronger and stiffer parts, and to end use where the part will go on a vehicle or an aeroplane, and it is expected to behave the same or better than it did with injection molding or the earlier process that it underwent.
So that brings me to the next question: the comparable use of the technology in India versus the world. Now, as we saw that the market size itself gives a reflection of how much it is adopted in India versus how it's done, and especially in the highly industrialized economies in Europe and the US. Now, my question is that what is the scale of adoption that you see in India? What are the major areas, some of the examples that you've shared with us already? And what are the potential areas where this could be used more?
Good question, actually. It's all about India as a country, our own DNA about product development, our products becoming globally competitive, and so on. I'll give you some data points for us to ponder about. If you look at the R&D investments as a percentage of GDP, India since the last 10 odd years stands at 0.7%, right? And if you compare it with somebody like China, it is 2.1%, which is 3 times. Now, look at their economy, which is already much higher. Look at the percentage, which is much higher. That means a lot of investments is going into R&D. Companies like South Korea have like 4.5% of GDP's investment into R&D. Japan has 3.2. So this is as a nation, we need to evolve in terms of making sure that we are innovating enough. We are spending more time in research, development, and innovation than just localization or making gradual improvements in products. So that's one of the things. Two, I think our education system also needs to evolve, and things like additive manufacturing, industry 4.0, robotics, automation should be an integral part of the course, and a better industry academia collaboration. So if the students are ready with this technology and clear about what they should be doing when they enter the industry, they would start demanding these products. So we ourselves put a lot of efforts working with the regional engineering colleges, the private institutions like Ganpat University, IIT, Ekega College in Delhi. So we are trying to kind of cover this gap, but then India is a vast country and we need to go a long way to make this happen. And I think another data point that I want to use here, if you look at the landline telephony adoption that happened in India way back versus the mobile telephony, in no time after adoption, the mobile telephony actually took a big leap and everybody had a cell phone in their hands. So I personally believe that as additive manufacturing moves to mass manufacturing and production, India possibly could see the same wave as it saw for telecommunication, wherein this technology becomes better and faster adopted in mainstream application as the industry itself has changed. Things like drones, they are not mass produced to the extent that automotive is. Their designs is different for dropping a package versus scanning a project versus doing something else as a process. Look at EVs, look at the design changes that are coming up with products. So all that will make the overall shift to manufacturing with additive much faster. And in the next few years, India could become a bigger player in additive manufacturing map of the world than it today is.
Wow, there are quite a few questions coming in. Can you hear me?
Yeah, I do.
Awesome. So quite a few questions coming in, Rajiv. Before I take one, I have one question on the mobility sector. Now here the 3D printing technology is being used to a large extent. Now we have Auto Expo this month, and from the responses that we've seen, the industry response to Auto Expo, it's not as enthusiastic as we would have imagined, and this is a media observation from a post-pandemic period. Right, so obviously there are a lot of inflationary pressures globally that are causing this and things like that. They may have nothing to do with industrial performance. But my question to you is that the EV sector is coming up in a big way in India. Even now it's less than 1% of the total vehicle population in India. But in the coming years, especially in the three-wheeler and the two-wheeler segment, it's taking a huge leap, which is great news for our country in terms of the reduction in pollution, right. And the sound pollution and other things. Aerospace sector is coming up in a big way in India. Bangalore, for example, is emerging as an industry hub for this space. Now, the adoption of 3D printing technology in mobility sector in particular, and in India in particular, what are your thoughts and what is your experience?
So this sector actually has been a mainstay of our business for a long time, from the leading global manufacturers like Volkswagen to the local manufacturers like Hero MotoCorp, Mahindra, Ashok Leyland, Suzuki. They're all using our technology for a long time. Now, as the industry is making a big shift, I also see a lot of work being given to the tier 1 and tier 2 suppliers to innovate and give a complete solution to the OEM. Till a few years back, I was seeing a lot of products being designed and then transferred to the tier 1, tier 2 suppliers for manufacturing or a little bit of an improvisation. So as that role increases, our SME sector and also the large tier 1, tier 2 suppliers have a big role to play in the overall vehicle development today. And that's where this technology is becoming very popular and far more adopted than it was a few years ago. About the Auto Expo and the muted response you are saying, I'm not sure what could be the exact reasons, but overall automotive market by the number looks pretty decent. And in the past, we had semiconductor issues and certain other things that the companies are grappling with. And I think some of them are thinking we don't have enough cars to supply. What do we do with showing more? But be as it may, I think electric vehicle becomes anything that requires weight reduction becomes a very important part of the application for 3D printing. And how it becomes so? Because we take away the constraints of manufacturing. Today, there are software tools available by the leading product lifecycle management companies to design products for additive manufacturing. So till so far, people have this concept for design for manufacturing, but now you can design for additive manufacturing, which essentially means you can work with conflicting constraints that make a product stronger yet lighter, make it more ergonomic, make it more free-flowing, because the molding challenges are not involved, etc. So as this becomes important, I'll give you a data point. In aerospace industry, for every half kg of weight reduction that you do, in 1 year, you would save 52,000 liters of fuel. 52,000 liters of fuel for half. So same thing. If you do weight reduction on drone, you get higher flying time. You do weight reduction on EV, you get better mileage. What is the equivalent word for range? Yeah, range. So
yes. The range anxiety issue.
Range anxiety, exactly. It is directly tied to the weight of the vehicle as well. So all these areas where a lot more innovation is needed for lightweighting, for using, we are still replacing metal by carbon fiber. Today, there are so many more advanced materials that we provide to our customers that they're easily able to replace many heavy components with lightweight, high performance materials like the carbon fiber and so on. So this industry, I think, is on a cusp where as the industry evolves into newer domains, additive starts playing bigger and bigger role in their overall scheme of things.
That's a great point, Rajiv, and that brings to mind a larger subject which we've been talking about in the recent years, which is Mission Make in India. Now, the manufacturers that I speak with are very keen to align with this mission. And as you know, there are several initiatives under that. There's Atmanirbhar Bharat, PLI scheme, the campaign to have at least a part of the semiconductor manufacturing supply chain in India, in whichever capacity. At least let's join the value chain of the semiconductor industry, which is really hugely coming up, and it's drawing investments from the US and other countries. Now, my question is that how do you see the industry, the 3D printing technology and the industry aligning itself with Mission Make in India? And how do you see your company coming in with its expertise to help out these newer industries that are trying to come up in India? Rajiv?
Correct. So actually, it couldn't be at a better time, because as additive manufacturing moves towards mass production, specific to Stratasys, we have launched new technologies, both on DLP as well as selective absorption fusion, as we call it, which enables you to do mass manufacturing at scale with 3D printing. These are some of the tools that will really help the newcomers in the industry, or people who are looking at playing a bigger role in Make in India, be ready and get their production output faster than they would traditionally do. And we are working with almost all large companies, both in product development stage, because if you also take a step back, you will make in India when you will design in India. So design anyway is a big play for us. And I think that we should also be very focused on design and innovate in India, because there should be a time when we see Indian products across the globe and say, wow, made in India. Great. So of course, make in India, design in India, and then there are tools available from us and leading manufacturers of additive to make this move flawless and very smooth.
Yeah, that brings to mind, and we have about 15 minutes to go. So I have quite a few questions, but I'll limit my questions to just one area from my side, and then there are a lot of questions from the audience.
Sure.
That important area, Rajiv, as you know, is sustainability. And now there are two related questions under this. One is that a lot of people know and may not perhaps is your companies and your personally your role and involvement in supplying and making sure the supply of life-saving equipments during the pandemic. Uh, the manufacturing of ventilators, for example, the PPE kits that you came in and your colleagues and your fellow engineers came in order to design them in warp speed, as the Americans call it. Uh, so that is one area where for disaster management, for example, in Nepal also, during the time of the earthquake, in the aftermath of the earthquake, we saw that 3D printing came to people's rescue in terms of giving them, let's say, the taps that could function, making them through 3D printers, installed overnight, and giving them with helping them with critical supplies of water, for example. So disaster management is one area. Making sure that PPE kits and life-saving equipments are available is another area. So one question is disaster management and these things in India and around the world, how 3D printing comes to the rescue. That is the first question, and then I'll ask you the second question on overall sustainability.
Sure. So disaster management, a great question. We have examples in India where 3D printers were kind of used for making PPE kits, ventilator equipment, the splitters, the masks, etc. at scale. And we collaborated and we gave our facility for anybody who wanted to use this. Many of our customers, like Volkswagen, like Hero MotoCorp, they use the existing setup of Stratasys technology that they have to make ventilators and PPE equipment for not only frontline workers, but also for the patients and so on. But this is when the disaster strikes. But if you look at disaster management and planning, these technologies will play a big role because you can actually simulate the environment, you can check for various feasibility studies and so on, and make sure what would be the best approach towards solving a problem which rises when the disaster strikes. So at the planning stage also it plays a very, very critical role. And creating topography as an example for multiple applications, not only for disaster planning, also for warfare planning and so on and so forth, could be various uses and applications of these.
Now the sustainability question, which is playing on everybody's minds, especially in the last 5-6 years, we have extreme weather events around the globe. Even as we speak, there are snowstorms and blizzards happening in the US, and at other times there are wildfires, and there are events that people have not experienced in India. For example, as you know, Rajiv, last year parts of India missed the spring season. For example, it just didn't arrive.
Correct.
You had winters and straight away you had the summers, right? So these weird and strange weather events are happening, phenomena are happening. So this is the right time, and this is the critical time when we need technologies to our rescue to help us deal with the climate change situation. So how does 3D printing come into the picture in dealing and in helping us address and achieve our sustainability goals that the world together has pledged towards and in keeping, for example, the Paris climate agreement that we talk about talks about keeping the temperature change within the next 50 years within 1.5 degrees, within the 1.5 degrees plus minus to pre-industrial levels. Now that's an ambitious goal with the rate at which the temperature is changing. So with that background, Rajiv, how is 3D printing technology helping us with the goal?
Great question. Actually, till about 5-7 years back, we should think about sustainability because we have to care for the next generation. But today it is here and now. We are seeing summer and summer, winter and winter, seasons are being missed out and so on, and it's becoming far more critical for all of us to look at how we can best serve and save our environment. So additive manufacturing as a technology is built in a way that there is very less wastage of material, right? So it builds parts grounds up, then actually cutting down a big piece of a metal and or forming a metal from another piece of a metal and so on. So by virtue of the way this technology is made, a lot of wastage is avoided, which is meaningful manufacturing. The other is there are a lot of new materials coming up, which are more green. So as an organization, Stratasys is one of the founding members of an institution called Additive Manufacturing Green Trade Association, and we have pledged ourselves to play a big role in making this cause possible. So there are new materials like PA11, which is commonly called as nylon 11, which are made from castor oil. These are far more environmentally friendly, and this material is very widely and can be used for automotive interiors applications and replace many of the conventional plastics that we use, which are far more destructive to the environment than PA11 is. And as we evolve, we are working a lot with material manufacturers. Stratasys itself has acquired a company called Covestro, which is their additive manufacturing business, let me correct. And we are ourselves working on a lot of environmental friendly materials. And at the same time, we have partnerships with companies like BASF, Evonik, and other leading material manufacturers in the world to make this dream a reality.
Great. That brings me to the first question from the audience, which is, all right, so the 3D printing industry has experienced significant growth in recent years, but there are also challenges that companies in the industry face. Can you let us know some of the challenges that Stratasys faces in India?
I would take it to the first point, that is, it's about the understanding of the 3D printing area and its adoption. And our challenge is that every time we engage in a conversation, we reinvent the wheel about why additive should be used, rather than which are the areas we can adopt additive manufacturing in. So it makes our, it just kind of delays the adoption of 3D printing at that customer, and they could have used it much better, faster in the time they spend on evaluating the technology. So I think this, and again, I would take the full ownership of educating the audience about 3D printing as leaders in the additive manufacturing industry.
And the next question is also on the same point, Rajiv, about education, about increasing awareness. That's a big thing. See, the thing is that there are industries where India can really get, to the meat of the trend, if you will, where it can, there are industries where it's doing really well, and these are the sectors that we need to identify in manufacturing, where we can really contribute to something that needs to be done. Now, 3D printing, I see, for example, is one such sector. But the thing that is mainly missing is awareness and education. And I've personally experienced, and so must have you, at the educational institutes where institutes and the leading institutes offer courses in this area. But the awareness level is still low. And you have centers of excellence and innovation, Rajiv, in your company as well. One is in Pune, if I'm not mistaken. Do tell us more about the centers of excellence and innovation that you opened, and your interaction, your collaborations with the academia to raise awareness about this.
So the first point about the Center of Excellence, we along with our partners have multiple experience centers where customers and prospects and anybody who wants to know more about 3D printing is most welcome. So we have these centers in Pune, in Bangalore, in Noida, and in Delhi, and Gurgaon and Delhi. So about 5 or 6 such centers in the country, plus leading education institutes like Ganpat University near Ahmedabad, AKGEC College almost on the border of Meerut, then IITs, IIT Bombay, IIT Delhi, they all, and even in universities in Kochi. So there are multiple experience centers that exist, and because India is such a large company, we just can't be everywhere at this point in time. And we are making our best efforts to liaison with as many education institutes, as many government institutes to make this technology more available to the customers and to prospects or anybody who wants to kind of experience this technology.
And in terms of the talent that you get in your company and that you experience, personally the quality of talent, the quality of people, the resources that this industry gets. Now a viewer shares with us a whole list of colleges that apparently 3D printing courses where they are offered. IIT Bombay, Birla Institute of BIT Pilani. So these are all leading, Vellore Institute of Technology. They're all offering courses in this area. So that brings up the question of the kind of talent that we have, because that's very important for innovations to happen, for the patents to be filed, for the country to become a technology hub, and the quality of work that should happen in India. So what is your experience of the educational the quality of the courses being imparted at our leading institutes? What are the pros and cons? What are the areas that are missing? Maybe, the interaction, as you said in the beginning of this conversation, the industry academia interaction, which is missing. So what are the areas that are missing, and how can they be plugged or bridged?
It's a good question. See, again, there are multiple institutes offering additive manufacturing as a program. Some of them run on industrial 3D printers, which work in a specific way, are very well tied up with the industry. And some of them are like a hobbyist entry-level printers where people can learn to, play with how a 3D printing works and how the technology is and what could be some of the possibilities. Now, Stratasys at our end, what we have recently done, again, it's a good question, and it's a recent introduction from our side also, that we have launched something called Stratasys Academy, wherein we have structured courses, programs, which take the user and the learner through the entire life cycle of 3D printing. We have to kind of make people aware about the potential of 3D printing and the problems and the challenges it solves, not just in the prototyping phase of product development, but across the product development life cycle. Also, it extends to any industry that you could think of. Let's say drones for irrigation, pesticide, same drone for medicine delivery. Things like electric vehicle lightweighting is such a big concept, and a lot of work is going on with institutes today. If you look at IIT Delhi as an example, they work in collaboration with All India Institute of Medical Sciences. A lot of devices that they are working on, a lot of surgical planning things that they are working on are done in collaboration with All India Institute of Medical Sciences. Dr. Suri is one of the big users. He's a very well-known neurosurgeon in this world. So we at RN try and bring industry and the user, be it any segment like healthcare or core manufacturing. But the idea is that we are able to implement the industrial applications or teach the industrial application to people, especially in the higher education, very well, so that they are fully aware of the problems that they can solve. At an early stage, at an introductory school stage, you can still play around, learn what it does and what role it can play. But as we evolve, we need to. So I'll tell you what a leading dean of a university told me. He says the industry comes to me and he says we need engineers of today, not engineers of tomorrow. So I need engineers who will come and start working today, not take internship or learn for the next 2 years and be productive. And that's the kind of ecosystem we collectively need to create. And so there is a lot of onus in companies like us. There is a lot of onus on the government. There's a lot of onus on private institutes to make it a part of the process and offer a meaningful outcome to the entire industry.
That's great. I have a question. I have a follow-up question, but before that, we'll take up an audience question, which is about the company. And it says, what are the plans? What are the plans for Stratasys in 2023? What can we expect from the company?
Our plans for some time have been, and we will keep building on this plan, is to move to mass manufacturing with additive. So polymer additive manufacturing into mass manufacturing is something that we would do. So we will provide you with newer technologies which are giving you the choices of materials, the choices of technology, the choices of product complexities that you want to design and manufacture in your own R&D lab.
Wow, that's huge, Rajiv, because the biggest dilemma, the biggest piece of the puzzle that the world faces when it comes to 3D printing, which is not true, which the industry insiders know, which is not true, is that you cannot do 3D printing at scale. And this new thing that you just announced and shared with the audience is going to completely change that game. And it's going to be a game changer for the technology and for the industry. Also, can you tell us a bit more about how this is going to play out?
And
With,
this, as
let's
I
say
said
with
earlier,
automotive, with an example.
sure. And this is where I think this is what I think will drive the next additive manufacturing revolution, which is the move to production. So today we are working with companies that make connectors, etc., who are totally done away with the traditional ways of manufacturing those connectors. So those connectors are mass produced on a platform called Origin One technology. They produce it and they are given to the OEM as, in the same way as they were giving their earlier injection molded part. So they have adopted a new technology, made it a part of the process, and today you have a series of 3D printers working instead of that. And what it is offering them to lightweight that particular part, to adopt to ever-changing designs that the customer asks for, and give them the complete flexibility.
Great. Now that brings me to the last question, and I think an ideal question to conclude this very engaging thought process and the insights, the series of insights that you shared with us would be something that you would share with us and our audience. 2 years ago, Rajiv, I should tell our viewers that Rajiv was one of the 17 samurais that inspired our awards called Samurai Awards, Industry Samurai Awards, that we give away every year. He was one of the leaders who we spoke to, and we wanted to know what in God's name is going on after COVID struck us. And he assured everybody, our readers, that don't worry, we're doing what we can do best. So Rajiv, I remember something that you had told us, and you said about 3D printing is that it can help usher in the maker movement in India. This is something culturally that we as a nation, as a society need. The craving, the urge to build something, to see something being created, a product being created right in front of our eyes. Because as a nation, we are a service-oriented economy, which kind of skipped the industrial part of the process. But with 3D printing, we can bring back the whole thing about making something and seeing the whole product evolve right in front of you, the whole feeling, the sentiment that comes from it right in front of your eyes. So the cultural impact of 3D printing on our country is something that, Rajiv, I need you to share with our viewers.
Sure. I would like to kind of relate it to the mission that we have, is to enable our users to create unlimited. Think beyond boundaries, just create, design, make things that you would like to without worrying about the constraints that it offers. In terms of making it a part of our culture, I think, again, the onus is on all of us, the viewers, you, me, our ecosystem, to ensure that this technology is made accessible and people have multiple use points and not just one engagement method with a 3D printing organization, right? So if you want to create something as an entrepreneur, do we have incubation cells which are promoting them to come work with them? Yes, we do. At a leading institute in Kochi, there is a medical device manufacturing that is happening, and a lot of entrepreneurs are using that facility. So how can we make it more affordable? How can we make it easier to implement? And let's not forget, India is a software country, and software has started to play an increasingly important role in the overall scheme of additive manufacturing applications. So today you can use the software to automate a lot of processes. So that's an area which would come naturally to all of us in India, because we are so used to intuitively use complex softwares for our workflow. So starting from software to designing, to manufacturing, to mass production, and giving affordable access to people for using 3D printing before they acquire their first industrial 3D printing is something that we would like to do along with the industry and academia. And that's, I think, something that will help drive this evolution in some way.
That's inspiring. Wonderful, Rajiv, for these thoughts. And to our viewers who are tuning in, you want to reach Rajiv to our magazine or to the company's statuses, you're very welcome. With all your questions, I'm sure you must have a lot of questions, and I hope And I'm also a bit confident that we may have answered a few of them. And I hope that we would have helped you think about even more questions about this technology, which was the whole idea of exploring this entire topic. This is a very, very important technology, ladies and gentlemen, for the future, for your career, for the future of India, for our industries. So do keep tuning into our programs to Makers and Movers. Keep in touch with Rajiv and with us about the technology. Thank you so much. You've been a wonderful audience to have stuck with us for this hour, more than an hour. Thank you so much, Rajiv, above all, for staying with us through all these years of the evolution of the industry of this magazine and overall the technology, its advent and emergence in India. Thank you, Rajiv.
Thank you, Anand. It's always a pleasure to speak to you, and thank you to our lovely audience as well. See you all soon.